the last topic, subtopic for chapter 1, okay, 1.5, which is the indeterminate forms and L'Hopital's rule. The learning outcome for this subtopic, at the end of this topic, okay, you should be able to learn how to apply the L'Hopital rules and to define the other indeterminate form. Okay, first we look at types of limits. Okay, there are two types of limit. Okay, first one is the determinate form and the second one is indeterminate form. Okay, let's look at what is the determinate form. Okay, this is the determinate form. Okay, let A and B be a real number. A and B is a real number. Okay, we find the limit for this function. We have this function, the limit for x minus 2 over x minus 3, where x approach 4. Okay, when we substitute x equal to 4, okay, we get the answer 2 over 1, so equal to 2. So the limit is exists. Okay, this is the first example for determinate form. And the second one, okay, second example for limit x minus 4 over x minus 3, where x approach 4. When we substitute x equal to 4 into this limit, into this function, we get, okay, 0 over 1 equal to 0. Also, the limit is exists. Okay, 0 over real number, we get 0. Okay, this is second one. Okay, the third example of determinate form is in the form of a over 0, where a is real number over 0. So the limit does not exist. Okay, for example, we substitute the value x equal to 4 into this function, we get 0 over 2 over 0. So equal to infinity. Okay, infinity means the limit does not exist. So this is the determinate form, the three types of determinate form. Examples of determinate form. The real number, 2 and 0, and also the infinity. So the real number and infinity is in determinate form. The answer for determinate form. Okay, let's look at the indeterminate form. Okay, the indeterminate form, when we get the answer for limit equal to 0 over 0, means the limit may or may not exist, or when we get the answer for limit is equal to infinity over infinity. Okay, also the limit may or may not exist. Okay, so for example, we have this function, limit square root x minus 2 over x minus 4, where x approach 4. Okay, when we substitute x equal to 4 into this function, okay, we get 0 over 0. So 0 over 0. Okay, this is the indeterminate form. Okay, the second example, infinity over infinity. When we substitute into this function, infinity, the value of infinity, so ln infinity equal to infinity, okay, over infinity, x infinity. So infinity over infinity is indeterminate form. Okay, so what should we do if the answer for the limit is indeterminate form? Okay, we must apply the L'Hopital rules. Okay, this L'Hopital rules. If we get the answer is indeterminate form, 0 over 0 or infinity over infinity. So we must apply the L'Hopital rules. Okay. So let's look at what is the L'Hopital rules. Okay, to evaluate the such limit, we will apply the L'Hopital rules. Okay, suppose fx and gx are differentiable function. Okay, and limit for fx when x approach a equal to 0, and limit of gx where x approach a also equal to 0, or limit fx where x approach a equal to infinity and limit gx where x approach a equal to infinity. Then, okay, the limit of fx over gx, okay, where x approach a, okay, equal to either equal to 0 over 0 or infinity over infinity. Okay, so we have to apply the L'Hopital rules. Apply. So, how to apply these L'Hopital rules? So we have to find the limit where x approach a for f prime over g prime. We have to differentiate f and gx separately. For gx prime is not equal to 0. Okay, how to apply the L'Hopital rules? This is the summary for previous slide. Okay, the step 1, we check the limit for fx over gx. If we get the answer in the form of indeterminate, 0 over 0 or infinity over infinity, so we have to apply the L'Hopital rules lah ni, L'Hopital rules. Okay, the step 2, how to apply the L'Hopital rules? So we have to differentiate f and g separately. And then step 3, okay, find the limit of f prime x over g prime x. Okay, look at this example. Okay, consider the following limit. Okay, limit exponent x minus 1 over x where x approaches 0. And also limit exponent x over x where x approach infinity. Okay, from the properties of limit we obtain. Okay, from the first example. Okay, we substitute the x equal to 0 into this function. Okay, we get 0 over 0. And the second example, for limit exponent x over x where x approach infinity. Okay, we substitute x equal to infinity into this function. We have infinity over infinity. Okay, so this limit we call the indeterminate form because in the form of 0 over 0 and infinity over infinity. Okay, let's look at this example, how to apply these L'Hopital rules in this limit. Okay, previous slide we have find the limit. The limit is equal to 0 over 0 in indeterminate form. Indeterminate form. So we have to apply the L'Hopital rules. We have to differentiate fx. We have to differentiate fx. Ni fx The fx is for numerator, okay, over gx. Gx is the denominator. We have to differentiate. So we differentiate the numerator is equal to ex. Okay, over the denominator, x equal to 1. Okay, then we find the limit for ex, where x approach 0. So equal to 1. We substitute x equal to 0 into exponent x. So equal to 1. So the limit exists. Okay. So you have to remember, need to differentiate the numerator and denominator separately. Okay. So the limit exists for this question, ex minus 1 over x. Okay, let's look at the second example. In the previous slide, we have shown that the limit for exponent x over x equal to infinity over infinity, where this form is indeterminate form. So we have to apply the L'Hopital rules. Okay, we have to differentiate the numerator ex. So equal to ex, and then differentiate the denominator x equal to 1. So the limit e exponent power x, where x approach infinity, equal to infinity. So infinity is determinate form. So determinate form, there are two types of determinate form lah. The solution for determinate form equal to real number and infinity. Okay, ada soalan? Boleh faham tak ni?
Boleh, madam.
Boleh? Okay, third example. Okay, find the limit for exponent to the power of 3x over x squared, where x approach 0, where x approach infinity. Okay, we substitute x equal to infinity into this function. So exponent power of infinity equal to infinity over infinity. So infinity over infinity, we have to apply the L'Hopital rules. So we have to differentiate the numerator. Okay, so we get this one, 3 exponent 3x over, okay, differentiate the denominator equal to 2x. Okay, then we can bring this coefficient 3 over 2 in front. Then we find the limit for exponent 3x over x. Also, we get this limit equal to infinity over infinity. Then we have to differentiate one more time untuk ni. Kita dah dapat indeterminate form lagi sekali kan. So we have to differentiate once again lah untuk ni. So differentiate this one. So we get 3 exponent 3x over, then differentiate the denominator x. We get 1. So we can bring this coefficient in front. So we get 9 over 2 and then find the limit for exponent 3x, where x approach infinity. So we get the answer. Okay, 9 over 2 times infinity equal to infinity. So infinity is the determinate form. Okay. Okay, ada soalan tak untuk ni? Setakat ni. Tak ada? Boleh faham ni semua?
Boleh, madam.
Boleh, madam.
Okay. Okay, let's look at the other indeterminate form. Okay, before this we have learned the determinate form is in the form of 0 over 0 and infinity over infinity. Okay, this is the topic for another types of indeterminate form, which is the indeterminate product. Second one is indeterminate difference, and the third one is indeterminate power. So let's look at the example of all these three, indeterminate product, difference, and power. Okay, the first one is indeterminate product. Okay, indeterminate product. Okay, when we find the limit of a function, okay, we get the answer is equal to 0 times infinity. And also infinity times 0. Okay, so when we get this answer for the limit, so we have to rewrite the product as a ratio, where fx over gx. Okay, by referring to this formula for this, by referring to these rules. Liate rules. L is for logarithmic, I is for inverse function, A is for algebraic, T is trigonometric, and E is exponential. So depend pada F lah. X. F is depend for F. If F is in logarithmic function, so we have to put L. Logarithmic is for F. And if the function involve algebraic, we have to put algebraic at gx. Okay, based on this rule. Okay, the second one is indeterminate difference. When we get the answer for the limit is equal to infinity or infinity minus infinity. Then we have to produce the indeterminate form of type 0 over 0 or infinity over infinity. We have to modify this function, the original function, to get the answer 0 over 0 or infinity over infinity. Then we can apply the L'Hopital rules. Okay, the third one, the indeterminate power. Okay, when the answer for the limit, we get 0 to the power of 0, okay, infinity to the power of 0, and 1 to the power of infinity. Okay, so how to solve this indeterminate power? Okay, we must take the natural log to solve this limit. Okay, let's look at example. Example 1. To evaluate the limit for x times exponent power of x, where x approach negative infinity. Okay, when we substitute x equal to negative infinity into this function, okay, we get the solution is equal to, we get the answer is equal to negative infinity times, yeah. And we substitute exponent power of negative x times 0. Exponent negative infinity. Okay, for this one you have to refer this note untuk ni. This rules. For ln 0 equal to negative infinity. Okay, therefore exponent negative infinity equal to 0. Kita gunakan yang ni lah tadi, yang first one. Exponent negative infinity equal to 0. You have to remember these notes. The second one, the ln infinity equal to infinity, and then the exponent to power of infinity equal to infinity. Okay, the third one, ln 1 equal to 0, and then exponent to power of 0 equal to 1. Okay, number 4, the tangent inverse 0 equal to 0. Number 5, tangent inverse infinity equal to pi over 2. And then the tangent inverse negative infinity equal to negative pi over 2. Okay, ni awak kena ingat lah ni. Okay, the first step tadi, when we get the answer negative infinity times 0, where it is indeterminate product, so we have to change this original question into the form of fx over gx. You kena jadikan in quotient lah, fx over gx. So we have to use the guide of ni, Liate rules. Okay, so fx. Okay, mana satu nak fx? So we depend on ni, Liate rules. So we have x. X is algebra and the first one. E is for exponent. So for exponent, we put it at gx. Untuk ni gx. Ini awak akan dapat gx fx over gx. So fx is x and gx is exponent x. Exponent x. Okay. So we get the new form, limit x over exponent negative x. Then we substitute x equal to negative infinity into this function. We have negative infinity over infinity. Okay, so this is indeterminate form. Then we can apply the L'Hopital rules. So the next step, we have to differentiate fx and gx separately. So we differentiate x, fx, okay, to 1, okay, over, differentiate the gx, exponent negative x equal to negative x, negative exponent power of ex to power of negative x. Okay, then we simplify. Simplify. Okay, then we substitute the limit. We substitute the value x equal to negative infinity into this function. So we get 0. The answer is 0. So 0 is the real number. Okay. Kita follow rules lah. Negative exponent negative infinity equal to 0. Okay, look at second example. The second example is for indeterminate difference. So indeterminate difference, kita ada infinity over infinity and the solution for limit for this function equal to infinity minus infinity. Okay, so we have to adjust. We have to modify this function. So we modify this function by using cross multiplying. Awak darabkan ni. So we get this new function lah. New form of function ln x minus x plus 1 over x minus 1 times ln x. Okay, when you substitute x equal to 1, okay, we get the answer 0 over 0. Okay, then we can apply the L'Hopital rules. So we have to differentiate this fx. So differentiate, we get this answer 1 over x minus 1. And then we differentiate gx, the denominator. So we get this answer. X minus 1 times 1 over x plus ln x. We use these product rules. Okay, we substitute x equal to 1. We also get the answer 0 over 0. Okay, then we have to differentiate once again. You have to differentiate this one. So we get this answer, negative 1 over x squared. And we differentiate gx once again. So we get this answer, x minus 1 times negative 1 over x squared plus 1 over x plus 1 over x. Okay, then we substitute x equal to 1 into this function. Okay, so we get the answer, the real number. The answer is the real number. So negative 1 over 2. Okay. So untuk ni awak kena mahirkan differentiation lah. Either using product rules, quotient rules, tu kena mahirkan. How to differentiate the exponent and how to differentiate the log function, trigonometric function, what we have learned before in chapter 1. Okay, ada soalan? Tak ada? Boleh faham?
Boleh.
Boleh?
Boleh, madam.
Example 3, the indeterminate power. The question is limit x to power of x when x approaches 0. So we get the answer 0 to power of 0 is indeterminate power. So we have to take ln, to take the natural log both sides. Kat sini ln y equal to ln x power of x. So ni the power of x, kita bawa ke depan, so x ln x. Okay, then we take the limit for both sides. Okay, limit ln y and then limit x ln x where x approach 0. Okay, and then we find the limit for this function. So we get the answer 0 times infinity. So is indeterminate product. Ini indeterminate product kan? Product. Okay, if indeterminate product, so we have to modify this function. We have to modify this function into fx over gx. Indeterminate product. So we have to modify this function into fx over gx. So we get this new form lah. So ln x over x power of negative 1. Okay, we have to modify this using Liate rules. Based on Liate rules. So you akan dapat yang baru lah yang ni. Ln x over x power of negative 1. Okay, then we find the limit where x approach 0. So we get the answer infinity over infinity. So infinity over infinity. Then we can apply the L'Hopital rules. We have to differentiate the fx so equal to fx equal to 1 over x or x power of negative 1 and then differentiate the denominator so equal to negative x power of negative 2. So and then we simplify this function. So we get this answer limit negative x. Okay, and then we substitute x equal to 0 into this function. So we get 0. The answer is 0. The right hand side limit 0. So the left hand side limit ln y where x equal to 0 equal to 0. Okay, then we find the value for y. We want to find the value for y. So exponent, we take exponent lah. Exponent to power of 0. Untuknya. Ni nak dapat ni lah. Kita dapat ln y equal to 0 kan. So you want to find the value for y. So y equal to exponent to power of 0. So equal to 1. Okay, then we replace the value for limit y where x is equal to 0. We replace it with the original question. So equal to 1. Ni penting ni, awak kena replace balik. So kalau tak replace ni, maka akhir ni tak ada lah. Okay. Okay, this is example for indeterminate power. So for indeterminate power, you have to apply the ln or the natural log. Example 4, also indeterminate power in the form of infinity to power of 0. Also, we have to apply the natural log for both sides. Okay, then we find the limit for the right hand side. So we get the answer 0 times infinity. Okay, 2 over infinity is equal to 0, ln infinity equal to infinity. Okay, then we have to, if we got this answer is indeterminate product, we have to transform this function into fx over gx. We have to use Liati rules. So we get this new form, ln x over x. 2 ni buat ke depan. 2. So the limit for this one, ln x over x is equal to infinity over infinity. Then we apply the L'Hopital rules. So we differentiate. Okay, we differentiate the numerator is 1 over x and differentiate denominator over x over 1. So we get the answer equal to 0. So ni dapat lah kan, ln y equal to 0. So y equal to exponent to power of 0 equal to 1. Okay, then replace back the original question. Y equal to this one. So equal to 1. Okay. Okay, the last example. Indeterminate form. Okay, we substitute x equal to infinity into this function. Okay, we get 1 plus 0. So 1 to power of infinity. Okay, we get this answer 1 to power of infinity is indeterminate power. Okay, then we have to apply the ln. Take ln for both sides. Okay, so we get this equation. Okay, and then we take the limit for both sides. Okay, ni both sides. So I'll substitute x equal to infinity into this function for the right hand side. So you akan dapat infinity. Okay, infinity ln 1 plus 0 ni kan, ln 1. So 0. So we get this answer infinity times 0. So infinity times 0 is in product, intermediate product. You have to transform in this function into fx over gx. Okay, use based on Liati rule. So we get this new form. So ln 1 over x over, ni bawa ke bawah, over x to the power of negative 1 ataupun over 1 over x. Ataupun boleh ni x power of negative 1. Okay, when we substitute x equal to infinity into this new form, so we get this answer equal to 0 over 0. Okay, then we can apply the L'Hopital rules. So we have to differentiate the numerator and denominator separately. So differentiate lah, ln this one. So we get this answer using product rules. Okay, over differentiate the denominator is equal to this answer. Okay, then we can simplify this function. Okay, ni boleh cancel. So we get this new form lah, simpler form. Okay, then we substitute x equal to infinity. So we get the answer equal to 1. Okay, then ln y equal to 1. So y equal to exponent to power of 1. Exponent to power of 1. Then replace back y, the value for y, with original question. Okay. Okay, this is the last example for L'Hopital rules and indeterminate form. The reference is from your future. Okay, ada soalan? Kita akan gunakan ni last chapter. Ada soalan?
Madam.
Ya.
Maksudnya yang Liati rules tu, maksudnya kita utamakan letak F dulu baru G tu ikut ln, inverse, atau dia juga.
Ya. Ikut ni.
Even soalan dia bagi algebraic dulu baru ln macam tu kan.
Biasa dalam ni dia akan
lagi.
in form of product. Ni kan product kan? In form of product ni. Yang ni kan? Product. Jadi awak nak jadikan dia in form of division. Kena ikut follow ni lah. Yang mana yang datang dulu.
Okay. Faham.
Kalau dia dalam okay. Ada soalan lain? Yang tadi yang paling penting awak kena ingat lah yang notes yang tadi ni. Dia punya ada rules. Liati kena ingat. Dengan yang ni. Kadang-kadang ada yang tersilap ni. Nanti awak dapat form yang tu salah lah. Okay, ada soalan? Tak ada? Tak ada? Okay, nanti untuk subtopik ni saya akan bagi task lah dalam Google Classroom. Tutorial tak ada lagi untuk yang ni. Yang ni akan kita akan applykan dalam chapter yang last nanti. Tapi syllabus baru ni dia masuk dalam chapter 1. Dia ajar dalam chapter 1. Tapi ni awak akan gunakan balik dalam chapter 3 nanti. So dalam tutorial tu tak ada lah untuk subtopik yang ni. Saya akan bagi task yang lain lah nanti. Okay, tak ada soalan Semua faham?
Faham, madam.
Okay, faham. Kita boleh stop sampai sini. So next, nanti saya akan bagi task Jawab lah. Okay, so awak punya test yang ni akan masuk lah juga. Dengan yang untuk minggu depan lagi satu by parts. Akan masuk sampai by parts. Tengok by parts tu satu soalan je. Okay, test week 6. Okay, soalan kita start sampai sini. Okay, thank you semua. Dia saya akan post task awak boleh lah